Hello guys. So now we're starting with question number 3. And question number 3 says, which statement correctly compare metals and non-metals? So if we remember when we talked about metals, non-metals, and metalloids, and again, just for time purposes, I'm going to put this right here. I want you to write this somewhere on your paper, maybe somewhere here at the bottom. Remember that we said that metals go to the left of the periodic table, non-metals go on the right of the periodic table. And when I'm talking about metals to the left, to the left of the zigzag line. And then non-metals are to the right of the zigzag line, the dark zigzag line. And the metalloids, they are found along the zigzag line. So then those are the locations. Now, properties of metals. Metals are malleable and ductile. Malleable means that we can hammer them into different shapes, into sheets. Ductile means that we can pull them into wires. Now, non-metals are brittle. That means that if you hit them, if you hammer them, they're going to break into pieces. Metals are shiny. They have luster, kind of like when we look at silver, at gold, or even like my pen. Look at the shininess of my metallic pen. This is a metallic pen. So they have that shiny look right here. My finger gets reflected. They have that luster. Now, non-metals are dull. They will not reflect another object on it. Now, metals are good conductors of heat and electricity. So if I put my pen near heat, it's going to attract, it's going to get hotter. Non-metals are poor conductors of heat and electricity. Then they will not allow that heat and that electricity to flow through it easily. Metals will allow heat and electricity to flow through them easily. And then what about the metalloids? I didn't put anything in the metalloids. The metalloids are going to have properties of both. So I'm going to put right here properties of both metals and non-metals. Metals and non-metals. So make sure that this gets written onto your paper. So then right here, do not forget this when I'm talking about properties of both metals and non-metals. We might have a question that is saying that an element is shiny, but it's a poor conductor. It's kind of like I have shiny from the metals and poor conductor from the non-metals. So that's what I mean when I say properties of both metals and non-metals. Once again, make sure that this gets copied on the bottom of your information of your question. I want to see it there. And now let's go ahead and go and try and answer the question based on this information. So then we're looking metals, the correctly comparison of metals and non-metals. Okay, so metals tend to be good conductors. Yeah, we put right here that metals are conductors of heat and electricity. Non-metals tend to be good insulators of thermal energy. So then that means thermal energy means heat. Okay, so then right here, this seems to be correct. Metals are good conductors, yes, of thermal energy. Non-metals tend to be good insulators of thermal energy. So then that means that both of these statements sound correct. Metals are dull. Metals over here, we never said that they were dull. Non-metals are dull. Okay, so this is false. So then they're supposed to be shiny and malleable or ductile. So then I'm going to go to the next one. Metals are good insulators. No. Okay. The insulators are the non-metals. So then metals are good insulators. No, these are supposed to be the non-metals. And let's go to the last section right here, the last statement. Metals cannot be stretched into thin wires. Remember I said that a ductile means that they can be stretched into wires. So then the correct answer right here is going to be letter A. Metals tend to be good conductors of heat and electricity. Non-metals tend to be good insulators, which is the same as poor conductors of heat and electricity. Of heat. They're good insulators of heat. Something that I did not mention is that whenever they use the word in any question, any type of question, whenever they use the word semiconductors, make sure that you label that as metalloids. So metalloids are also called semiconductors. Thank you, guys. See you at next question.